Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial we're trying to see how to work with XGBoost, right? So it's a very powerful machine learning library that allows us to do gradient boosting. So to install, just go and click install XGBoost to install this particular package. Now what is boosting and then what is gradient boosting? So we have backend, we have boosting. So boosting is an ensemble technique of adding new models to correct the errors made by existing models. So what do I mean by that? So for example, you create a model, right? But this model is a weak classifier. So you're going to build on that model to produce a strong classifier. So just like the English word boosting, to boost something means to make something stronger, to build upon something, right? So you are trying to build on an existing model which is a weak classifier to create a stronger classifier. So in doing that, you are supposed to eliminate the errors, right? So that is where the gradient comes in. So it's called gradient because we are using a gradient descent algorithm to minimize the losses during new model creation. So let's see how to work with it. So in working with XGBoost, it's a very powerful machine learning library. You have to know some things, right? You have to know that it works only with numerical values. So in case you have categorical values, you have to convert them using one-hot encoding or label it in any format you want to convert them into numbers. Then it also has a D matrix, right? So the D matrix is a special matrix that allows you to improve the performance and efficiency. So you can convert the entire stuff into D matrix and work on them, or you can work on them straight away without converting them to D matrix. That is the basic stuff you have to understand. And then the reasons why you have to use XGBoost is that just like any machine learning algorithm, you have to it is used and is built specifically for the speed, right? It's very fast, and also for the performance too is also very good, right? So let's see how to work with it. So this is a workflow. Just load your data, and if it's a categorical data, you have to one-hot encode it or encode it in any format to bring it into numbers. Then you split them, you create your model, you fit them, then you do your prediction. So let's see how to work with it. So we'll be using this particular data set from UCI machine learning repo. And then it's about bank marketing, right? So this is the data set we're working with. So it is trying to check and it's a classification problem. So the goal is that you're going to predict if the client will subscribe a term deposit, right? So that is what you're going to do. Is a client going to subscribe, or is the client not going to subscribe? So that is the data that you're working with. So let's see. Let's load our packages. So I'm going to load our EDA packages, that is pandas, numpy, and then XGBoost. Okay, so these are data sets. So I'm using this particular format to split it because that's how the data sets look like. Okay, so let's check for the head of it. We check for the head, we have this particular data set. We have age, jobs, marital, education, default, and you realize these are all categories, right? They are not numbers. So we need to convert all of these things into categories, into numbers. So that if you check for the shape of our data set, we have about 41,000 data points, then 12 columns. Then let's check for the column names. Then we have age, they are normal good column names. And also let's check for missing values. Okay, perfect, there are no missing values. And then let's check for the data type. Perfect, so whether these are objects, right? So you have to convert all of these objects into numbers so that we have to work with it, because in machine learning we only deal with numbers, not with text. Even if it's text, you have to convert them into numbers. So let's see our label. Is going to be a label that we have no or yes, right? That means that is a person going to subscribe a term deposit or not, right? So let's see another way of doing a quick data profiling of the entire data set. So we just go with import pandas profiling as pp, then you go with the pp.profile report to generate a profile report of the entire data set. It takes time based on your data set. Okay, perfect. So now just finish. You can see it from here. So we have the overview, which is this one. We have the variables, we have the correlations, we have the missing values, and then we have the sample. So let's see what is given to us. So if you do the overview here, realize that we have the data set number of variables, which is 22, the number of observations, that is the number of data points. There are no missing value. There are some duplicate rows, that is about 12 of them. Then total size in memory 6.6, and then average record size is perfect. So if you check for the variables, you also have these ones here. So you can be using these ones to check it. So let's go up a little, and then so these are variables that we have for each and every of them, the mean, the unique values. Then let's check for the correlations. So for the correlation, give us two different types of correlation. We have three different or four. We have the Pearson correlation, and we have the Spearman correlation. You realize that it also changes, right? You may not notice that it's changing, but you can see here that this is a Pearson correlation, the Spearman correlation here, then you have the Kendall correlation, then you have the phi k correlation, right? So these are the features that are correlating, how each and all the features correlate with one another. Then the normal record correlation. Okay, perfect. So now let's see some of the missing value. This is using missing NO to create this particular plot, and then we also have some sample, first row and then last row. Perfect. Now let's see how to convert all of these particular stuff, because we realize that from here, from our plots, we had some categorical data, right? I don't know whether you could notice that here, right? You have some about 10 of them, so you have to convert these 10 into numeric to be able to help us with our machine learning aspect. So let's try that one. So there are several ways you can do to encode our categorical data. You have use category itself, you can use get dummy, you can use label encoder or label, but now that if you have two different types of like the yes and no, right, you can use this particular option to do that. You can also use custom find and replace, which is a most tedious one. Now let's see how to do that. So I'm going to get all the columns that are objects with this. We have jobs, married, child, education, and then so the first method of converting them into numerical values is to use get dummies, right? So pd.get dummies, you're going to create a whole data set with that particular option. Take some time. Voila, that's finished. So that is how to do that. So it's going to convert even some of these ones into categorical or into categories or into encodings, right? Or not encoding. That's one method. So the next method is that I'm just going to get the unique values from each and every of them, and then use that same idea to create and to encode them, right, by categories. So let's see that one. So I'm just going to go with for I in df.columns, then I'm just getting only the objects, and then you're going to find the unique values for each and every of them. Okay, so we realize that job has housemaid, service, admin, blue collar, technician. It's going to encode them as 0, 1, 2, 3, 4, 5, 6, like that. Just like for example, like loan 1, no, and then yes or no. So we're going to 0, 1, 2, or 1, 2, 3, based on how it's going to be. So I'm going. Let me store it inside a different variable of df2. Then let's change the entire stuff. Create a whole new data set for that. So we are going to be replacing it as category. Then we're going to use cat encode to encode the entire stuff. Right. Perfect. So that's finished. Now, if I go and check for one of them, like the jobs, realize that now it's 37707 instead of it being housemaid, service, admin, blue color. There are a lot of them. That's why we even have 7. Right. So if I even check for this one as unique, realize that it's going to give us so df2.unique, df2.job.unique. That we have about 11 of them, right? Very interesting. Okay, perfect. Unlike the previous one. Now let's see for the data types. Now we have all of them as numbers. So we have integers, and then we have floats. Very interesting. So we can work with it now. So if I check for the labels, that is the target. We have 0 and 1 instead of yes and no. Then the shape still remains the same. So let's create our features. To create our features, I'm just going to select from the first value to the 20th value based on how data set was prepared. So that this is going to be our S features, right? Perfect. All of them are now in numbers. And then for the labels, it's going to be our Y. Perfect. So the next step is that here we can do total. You can convert this entire stuff into D matrix and then split them, or you can split them into training and testing data set and then convert them to D matrix. Let's go with this particular method. So I'm going to import train test split from Sklearn module selection, and I'm going to split them on 2030, right? 2080, rather. Then if I check the shape now, it's going to be 32,000, so 41,000. Now let's build our model. So we build our model based on 3 different classifiers. So we'll be using gradient boosting from Sklearn itself, and then we'll be using C3 from Sklearn, and then we use our XGBoost, right? So that's the main classifiers we'll be trying to build. So let's work on it. So the first one is going to be from ensemble method using gradient boosting classifier, and we will check it, right? So I'm just going to create my classifier here, the gradient boosting classifier. I'll fit and train, I'll build a model with our training dataset for S and then for Y. Perfect, right? So we have it here. So to the next one, so this is going to be our prediction to be predicted with this particular step, right, that we have here. So finish prediction, let's check and see what we have created. So this is going to be our right predictions. Now in case I want to check for the accuracy of this particular model, I'll just do it from Sklearn.metrics, import accuracy score, and then let's work on it with the Y test, right, in our Y prediction, the one that we stored in this particular variable. So let's check our accuracy of our model. Oh, that is 92.4, which is not that bad. So our model is very, very high, right? 92.4, because the gradient boosting. This is a very powerful model. Now let's use the decision tree classifier and see how much it's going to give to us. I'm just going to import decision tree classifier from Sklearn.trees. Then I'll create a tree classifier, D3 CLF classifier. Then let's build a model by fitting our S train and Y train, which is very fast anyway. Then let's see how to predict on it. So I click my model.predict S test, then Y predict 2. Perfect. So you see that that here gave us 0, but here it's giving us as 1, right? 0 is 0, same thing, 0 0. That means that this model is good, but it's having some errors in some places. So let's check for the accuracy of it. So if I go for a check for the accuracy of it, we have 0.89, which is not that bad, but it is like very low. Right, this is 0.924, this one is 0.892, which is lower than the gradient boosting. Now let's use the XG boosting to see how much it's going to give to us, right? I'm just going to initialize it. So in XG boosting, we have SGB classifier, SGB cursor, and several of them. So let's initialize it with that SG classifier. Then we build a model. So that's finished building with the default parameters. So what you have to notice about SG boosting is that it works with leaves, right, instead of trees. Decision tree works with trees, divides it based on trees, but in SG boosting, you're going to use leaves. Perfect. So let's see how to do that. So I'm just going to predict with our XGBoost classifier.predict, just like normal way of prediction. And let's check our prediction and see. So this one is 0 0, just like the gradient boosting of Sklearn. And let's check for the accuracy for model. So it's going to be accuracy score. Then I'll pass it on my Y test and my prediction that I have. Perfect, which is 92.2. So this is 92.25. The other one was 92.4, and this one is 92.4, and then this is 89, right? So that means that our gradient boosting from Sklearn is giving us a very good classification or accuracy. The same went with our SG classifier. So let's create a single prediction and see how to do that. So I'm just going to get the first value here, and you try and predict whether it's going to give us a 0 or 1, whether it's going to tell us that the person, right, is going to subscribe to the term deposit or not subscribe to the term deposit. So to do that, I have to reshape our dataset to a single sample, right? That's how we use reshape this particular option. So this is for our decision tree, for our gradient boosting, and for our SG boosting. So let's try that one. So this gives us a 0, that means that the person did not subscribe based on the dataset. Then let's try for the same stuff for gradient boosting. Also 0, right? The person did not subscribe. Then let's see for the SG boost. So for the SG boost, let's see what it's going to give us with the same format we have. Perfect. So this is one of the errors that comes when you are trying to work with SG boost. So that's one of the errors that comes. The reason this error comes is because there's a mismatch in the feature names. So this is age name, but in XGBoost it's going to put them in this particular format. So that's what I'm going to give them. So there are several ways of solving it. So the solutions for them is that you're going to convert the entire data frame to a matrix as S matrix, like this format here, right? This format, and then you train your model, and then you do all of this. This format is going to work perfectly. Or you're going to use double bracket for the ilog, right, for your particular dataset, which is the one we're going to use. We're going to set the feature names well. So these are the basic methods, but the one that works perfectly is the second method and then the first method. So let's see how to work with our second solution. So I'm just going to put double bracket around our location, right? So this is going to be the same stuff. And then if I apply it without reshaping, this is already reshaped. then it's able to see it perfectly well. Give us a 0 just like the previous one. So let's see the feature importance. What are the important features by which any of these classifiers is giving us this particular result? So I'm just going to use matplotlib. Then I'm just going to check and see for our feature importance. So from our result and our classifier is going to be based on our duration, right? And then the Euro ball 3, then this one. So these are the basic ones that it's going to use to give us a particular prediction, right? Perfect, with the S-score. Now the alternative method is that we could have used data matrix. So let's see how to work with that. So I'm just going to create a data matrix from our dataset. Our S is our features and our Y for our labels. And then I'm going to set the parameters. So as I said, it's working on leaves instead of trees. So we have a maximum depth of 3, eta of 1, silence. These are all the parameters to do hyperparameterization or hypertuning, right, of our parameters. Then I'm going to create a new classifier. So this is another way of creating a classifier. You just train it with our parameters and then our D matrix that you created, then the number of boost round, right? So you can just set this value to any number that you want. Perfect. So we can use the same to check for our decision tree. How is it going to do? So we're going to create a decision. We're going to plot a decision tree with this particular classifier, with our first classifier, without the data matrix, and then the one with the data matrix. So this is going to be the one with the data matrix. Perfect. It's not that clear, but let me change this one. Let's make this one 50 and see. Okay, perfect. So this is now this give us some better one. So this is how it's going. So if the employer is of this particular amount, yes, right, duration is this, yes. So this is how it's going to split it, right? This is based on leaves, as I said, right? It's not based on just trees. It's going to be based on these individual nodes to produce a particular prediction. Perfect. Now let's see that one for the main classifier without the data matrix. Perfect. So this one gave us totally different. So we have here. So let's make it 50 and let's hope it also give us a very clear one. Okay, so this is not that bad. So we have an employer. So this is a particular value just like we had here, right? Particular value almost the same. Then the duration is almost the same, 173 here, but here is 179. Then the number of days and then the list. So this is how it's working on it. Perfect. So let's see our feature importance too. You can also use the same thing to check for our feature importance. This was just for the how it is making a decision. So we have our plot tree, right, decision tree. And you need to get graphics to help you with that here on any media system or even in Windows. So we're just going to go with our feature importance again on our classifier built with the data matrix. So we have to run it twice for it to be clear. Okay, so realize that this one is totally giving us something different. Although the duration, the cost, conf, IDS, and then the Euro both are the three main features that are going to be using, just like the previous one that we had here, right? 1, 2, 1, 2, right, 3. So that means that duration is very, very important on both of the classifiers, either with the classifier built without the data matrix or the classifier built with the D matrix. Let's see how to interpret this model. So as we have been learning so far, from henceforth you have to just add interpretation of it to it. So we have our using line 5 and sharp. You can also use line, right? So in case you see how to do that, you can let me know in the comment below. So import line 5, then from line 5 import show width. Then let's see how to work with it. So this is going to be for main classifier. You cannot see it well, so let's change it to the light thing. Perfect. So let's see what it's going to give to us. So from here, realize that the number of employee, like the number of this particular feature, right? I don't know what this feature is. Let's check what that feature means. From here, NER, I've forgotten what it means anyway. Okay, this is for 3 months rate, number of employees. Okay, so the NER employed is number of employees. So from our feature, realize the number of employees is also part, right? It's part of a very, very important feature that's we use for the prediction, duration, and then the values. Just like this graph also showed us, right? Duration was there. And the other one too, the number of employees also there. Anyway, different models. Okay, so that is how it's going to be, right? So these are the weight for each and every of the feature, how they are going to contribute to give us a prediction. Perfect. And then let's see that one for the classifier built with the data D matrix. So here we use months, but here it was number of employees, duration, and then the employer varied, right? But here it is EBOR months, then totally different, but it still makes sense anyway because some of them are still there. Okay, now let's see the same thing for our tree model, decision tree classifier, which will take a longer time to do that. Perfect. So here also give us a totally different stuff, right? So these things are the features, right? So to get the features, can just add the feature names to it. Perfect. So that is what the decision tree classifier is giving us. Now let's see some other stuff you can also do. Like to able to even plot some of the, that's why it took a lot of time. So you're trying to plot all of these things. So this is an image here. You can zoom in for it anyway. Okay, now let's see how to do a prediction and to explain our prediction that we had already. So this is going to be a prediction. We realize that we were predicting for 1. We want to explain why it gave us that no term deposit subscription, right? So let's see why it's giving us this particular option. So we'll be given our classifier, our main classifier, then our test data, right? And then you show feature values, right? You can also add the names, but let's go straight away. Add the names first, then you add the names to it. Okay, so this is why it gives us 0, right? 0 means that no subscription. And then it's giving us the number of features it is using to give us this particular probability, right? Or this particular prediction. So this is not very clear, but to see it, well, we have to create a column, a feature name. So let's see that. So I'm just going to get all our columns. Yes, I'm going to be using this one as our feature names. So that is this one here. Then I'm going to supply this feature name that we have into the same stuff we had initially, right? So two feature values, true, then feature name is going to feature names. So here you can also add a class, right? If you want the class name, it's going to be class. So let's try that one. So it's going to be class names. So let's try that one here. Class name. So to realize that we had no, right, for first one, and then yes for second one. So I can supply these class names here. So here is going to be target names, right? Target names, not class names. Okay. Then I'll set it as class names. Perfect. So let's try and see. Perfect. So we have our target name. Now this one gives us a probability of no because we set our target names as a class name here. Then the features that it's giving to us, right? So duration is one key feature. Non-employment is another key feature. So these are the features that are contributing to give us this particular no probability. Perfect. So you can also use sharp. So let's see how to work with sharp. So just going to import sharp, then sharp.init just to initialize JavaScript to help us with our plotting. Because I said JavaScript has been initialized. Now we are going to use a tree explainer because it's an SG, it's a tree-based algorithm, right? So we'll be using tree explainer. So SGB classifier, going to create an explainer, and you create a value, right, with our train. I use test or train, any of them is going to work. To see it, right? Any of them is going to work anyway. But yeah. So let's with our train dataset, can use the test dataset, it's going to work. Can use the train, it's going to work. So now we're going to use just going to generate a summary plot of the most important features that are going to be used to give us any prediction, right? So the summary plot, sharp values, then a string. So it takes some time. So now just giving us a very nice plot of our most important features that are going to be used to do our prediction, right? The feature value and the colors are very important also, right? Which of them are contributing, are pushing it away from the base value, which of these features are pushing it towards the base value, right? For any prediction. We have duration just like the previous one we had. We have employment varied. We have number of employment, which is very important, just like we had the previous one. And these are based on the order of importance. Very important. So thank you for watching this long tutorial. In case you have any question or contribution, you can just place at the comment section below, and also check the links below for some interesting stuff. In case you need help in any way, you can let me know. Thank you and stay blessed.